attending any conference, it's incredibly important to be there. That's kind of the only way to really dedicate your time to be there and kind of be immersed in the whole thing and not distracted by other stuff going on, even if you do get distracted with interesting conversations in the hallway.
Hi everyone, thanks so much for coming us today. I'm Xiaofan. This is my first time come to CppCon as a speaker. This is also my first time joining to CppCon face-to-face. I'm really excited today. Okay, I'm going to share a new framework called ZeroErr. I made in recent 2 years, which mixing assertion, logging, unit testing, and fuzzing together. Yeah, this is random things. It could be helpful for you to build a safer modern application. Before we get started, let me first introduce myself. My name is Xiaofan. 7 years ago, I came to America, studying computer science. And last year, I got my PhD from Israel side. I've been studying automatic testing of multi-threaded programs. During my PhD, I have papers related to symbolic execution, concurrent execution, for improving those parallel program testing and detecting and fault detections in concurrent data structures. For example, data traces. Now I'm working in NVIDIA hardware infrastructure team. My job is about designing domain-specific language for registers. Okay, let's get started. First, let me tell you the story of ZeroErr framework. 2 years ago, I was still a PhD student. Being a researcher, that is always a nice time for me. So you could do a lot of things. You could try the newest technique. You could really make the things could be influence for others. So I'm really quite exciting to see the paper's influence. That's most enjoyable part of the job. But things has two phases. There are also some painful time for me. One example I will say, please think you are a PhD student. This is your final thesis, and you will be called a doctor after you graduate. Your deadline only left 2 weeks, but when you collecting the data, there is one experiment log date that's showing something blah blah error code something. Then okay, it must make something wrong, right? No other choice. Let's try to figure it out and debug it before the deadline. So. You know what is the difficulty in debugging? The debugger sometimes won't work because for complicated data structures, you have too many linkage between nodes to check. There are so many information. So that I heavily relies on the logging on those information to debug it. So let's have a look what I have to print. There are some customer classes, structure date. Definitely those structure date class are the most common ones, like containers. We have some data that are in map, which indexing using a string. There are smart pointers, which when they use in the project, And there are also third-party libraries like LLVM, which is a famous compiler infrastructure library I use. So there are many different types that I have to print. I was using glog and the smart assertion library to make the output can both used by log and assertion. So I have to make a huge list of printing functions, like this one. Most of them are right of my customer data structures or customer containers. So I was thinking, could I make a template-based library focusing on printing those types and could be reused across different products, right? Yeah, that's the idea. However, there are many issues in streaming operator implementation. First, there are namespace pollution. So if you write this function, you must define it in a global scope. So it's sometimes hard to be to control when to use those functions. Second, it's also hard to implement with templates. Don't worry, I will explain this later. So another one is there's no extensibility. So if the library will define the template, then users lose the ability to define their customer template to override it. So that's an issue. And you can easily customize, you cannot easily customize the behavior for printing the same time for different scenarios. For example, if you want to print additional line breaker, it's hard to configure that because this function is not stateful and no additional parameters could be passed into the functions. So I was thinking maybe I should not use a stream operator, and a better way is to make the log using a stringify function with a format-like interface, and we can implement it as a stateful functor, like this one. So you could see, as a functor, you have states, right? We noticed that both logging and assertion, even more, the check in unit testing, they all need pretty printing. In an assertion macro, no matter it is used in user code or in unit testing, it's also quite helpful if we can print an error message when it's failed. In this example, assertion in print the message, A should not be 0, and the input as well. I think those log and assertion macros are the ones that I'm looking for. So that, I was thinking, maybe what I need is a framework that makes assertion, unit testing, and logging, they all use the same printing interface, other than a simple Stringify library. Okay, let's go back to debugging. It's a bad habit for me when I'm working on something urgent. I usually get off the topic. You may ask, then did you find the bug? Yes, and actually inside a unit test case, I think I have tested and there is no error detected. Then the question is, why it passed the test? Here is an example shows what happened. Let's say we have a function, pass expression, need to be tested. Inside function, there is a simple cache system which will cache the result to speed up the next time when you see the same input. So if cache not hit, we will run the pass function which did the real work. Otherwise, we will return the clone expression from the cache system. Okay, there is a bug in clone. I believe everyone made those kind of bugs. It's quite annoying if you write a clone function in the class. 1 month later, when you want to try to quickly change something, you add a field, which is a member variable, but you forgot to change the copy function. Then not all the information, some of the information is missing. That's a quite common mistake we may make. However, why the pass test? This is what happened. Did you see what's going on? Yes, there is a space. So the cache didn't work, so that U1 and E2 both created from pass the input function. Of course, the bug is not detected because you didn't run the code. Yes, I should test the clone function individually, but I was thinking to test the cache system as well, but made a mistake. However, my point is, there's no way to check if the cache system worked or not
by only looking at the output. One simple idea is we can add additional log in this function. If there is any side effect, we can write to the log to visualize the side effects, so that if there is a way to check the log, it could be very helpful to detect if the cache is hit. However, the most common log system, they will write the output to file, and there's no way to check the log message in memory. So if we can have an idea like this, we add this log and we use a macro, for example, log get, to try to see if that's get the log in the memory, so it could be more safe. Some of you may think always return error code could be a solution. When we design the API, if we can always distinguish the output by return different error code, we can know that which branch we are taken. In the left-hand side example, it shows the case. If error 1 and 2 occurred, they will return 1 and 2, those error codes, to make sure the unit test can verify that. But you will see, if we use a log, there could be more information written to the output. First, we can write error message to write human readable message to show what is the error. And we can also print some value of the contents, what the variable it is. Comparing them, we could find a list of benefits of checking the log. First, there is no need to change and redesign the API. Sometimes it's more convenient. When you're dealing with some old system that already have a stable API, there is no error code that could be returned, right? Then you also didn't need to maintain the error code. Even though maintaining a error code is not that hard, but it still needs some work and coordinate with other people's, right? If they are made by different people. Another benefit is you can check detailed information, like the error happened, what is the context. And if you want to trace this stack, additional information could be also collected. Then it also makes sure a path is taken, since you can add log at any point, but error code will only be used in the return statement. Next, let's talk about fuzzing. Fuzzing is a pointer. It's a popular method to automatically generate test cases for you. However, usually the fuzzing engine will generate a single input for you, which is piece of string. Not all the APIs are simple as the example. For more complicated data structure, we want to verify if the input fits in the data structure. And we want to mutate specific data structure instead of the string, so that the generated data is always suitable for that data structure. Yes, there are some third-party libraries support structural fuzzing. For example, FuzzTest, which influences this project a lot. However, I think there are some benefits that integrate the structural fuzzing filter into my unit testing framework. First, it can directly use all filters we just mentioned. Second, fuzzing didn't need to be implemented assertion, and the API keeps the same. Third, you can write fuzzing test as well as the unit testing case so that they can share some code base. Due to those 3 points, I decided to make a new framework, ZeroErr. It provides a way to make logged data can be accessed in unit testing so that we can verify the target function is not only returning the expected value, but also taking the correct path and context value is verified as well. And it provides printing function for right composition types like a container. User can also easily extend the pretty printing function by adding customer rules. Assertion can be used in both source code and unit testing code, and failure can be logged. All those features mentioned above can be used in fuzzing as well. ZeroErr have highly influenced by those three libraries. You will find there are many similarities functions provided in ZeroErr that's inspired by those libraries. For example, the unit testing macros are for assertion have very similar function to doctest. The printer pattern is inspired by the debug macro, which is a library for printing any type using the type decomposition. The Fuzzing API is inspired by fuzz test, which is structural fuzz test framework and works coverage-guided fuzzing engine like Leap Fuzzer. However, ZeroErr have some unique features that those libraries don't provide it. I will show you a few examples in the following slides. Okay, let's go to have a look about some examples. This assertion example shows the usage of ZeroErr framework. It's a header-only library, which is split into two parts, headers and implementations, which is very common in the many header-only libraries. We could see it use a macro ZeroErr implementation to control enabling the implementation part in the current C++ source code. Then, the target function is a Fibonacci function. You can see we can use require macro to check if the condition is satisfied or not. If failed, there are additional error message could be printed. In the following part, test case is a macro that rejects a unit test case with the name Fibonacci test case, function test. It checks output for calling the fib function. The last check assumes this function fab will fail and throw an exception due to the assertion not satisfied. In the left-hand side, we can see the output of unit testing. It presents the assertion expansion result and the error message. In the bottom, it shows the summary information of the current unit testing, how many cases and assertion are parsed, warning, failed, and skipped. Here's a logging example. The log macro has different severities. Log is the basic case. In addition, there are warnings, error, and fatal. Log macros are structural logging. You can use it like a format function, and it can print all basic types: integer, float points, pointer, string. The next line shows it can also print compositional types like containers, tuples, pairs. Log macro has a list of varieties which provides additional functionalities. Like log if can log when the conditional is true. Log first will log only once when the condition is true. Warn error will log every 2 times. Warn if error will log every n times once the condition is true. So except those, there is a dlog is a wrapper which can make sure that macro is only used for debug mode. Here's the output for the example. The output is optional colorful to help quickly find the error message. It also contains time and fail paths for each log message. The next example is reading the log. Here is the example shows how to use log get macro and get log function, which is the real API it called it. We use the same example, pass expression, which accepts the string as the input and use cache system to speed up the parsing. When the cache hits, there's a log recorded. Then let's see the test case. We first need to suspend the log system to make it stop flush log message into the file. They will keep all messages in memory, which gives us a chance to read the log. We can use the log_get macro. Those 4 parameters are target function, the prefix of the log message, current is cache hit, the field of the message. Since we used name field, we can see in the log message of the cache hit, there is a curly brackets which contains the name input. So this is the name of the field. So finally, you need to give a type. Since the log message, we want to remember the type information. So once accessing, you need to pass in the type of that field. Next, there is a fuzzing example showing the last piece of this project. We know fuzzing is a proven technique that can automatically detect error cases. Different than the unit testing, fuzzing do not need user to provide it an input, but it will use randomness and coverage guided method to find the input, which can cover new paths that the other groups never went there before. In another aspect, fuzzing is also quite like unit testing, since it's both need an interface to call the target function and a piece of code to verify the result, to verify its correctness. However, in the traditional fuzzing framework, there's no way to check the log message, so it has the same issue once the function returns the same value. There's no way to verify the expected path is executed, so we add a list of structure-aware fuzzing APIs to support working with this libfuzzer to run customer fuzzing test. In this example, we can see a macro fuzz test case. This is similar to test case macro to register a fuzzing test case. The main API is the macro fuzz func, which receives the lambda function. So this is a main API. Inside it, we can see the lambda function receive an unsigned integer vector as the input, which is the same as a target function. Find the biggest and find the biggest. So here is the function. So it will call the target function and verify the result by checking if the answer is greater or equal than all the elements. If the vector size is 0, we will check the log to see if the target correctly working, handles the case and produce a warning log. There is a few other APIs. Like this with domain is an API to set up the domain of the input. Here, since the domain which contains could be used for a container, the input is a vector. We can compose the domain by using the container of the container of and in range 2 functions. In range will allow generate random integers. Type is unsigned integer from 0 to 100. The function container of can convert the domain of this single integer to the target vector, which contains contains that integer. So there's another API with seed. Function can provide a list of initial values for those input as the seeds. Finally, there is a run function which triggers running the fuzzing by 100 times. It's also quite easy to compile and run the fuzzing test. Using clone and libfuzzer can easily do that. During compilation, we add the sanitizer flag, fuzz no link. This will instrument coverage counting instructions. Then links a special version of libfuzzer will without main function. Then you should see the following information printed and the fuzzing will start. To summarize, what makes ZeroErr different? First, it proved a coherent solution for mixing assertion, logging, and unit testing and fuzzing. Second, log data is structural and accessible. If you have a function which is hard to check its side effects, so you check the log. When you want to write a log, usually like a specific thing happens, a side effects happens, so something important happens. If you cannot easily check the side effects, then you check the log. Third, it has a structure-aware fuzzing API, which allows all other features could be used as well. There are 5 major components in this library. Assertion provided a list of macros can be used both in user source code and unit test case. Once assertion failed, the failure case will be logged by the logging components. The logged data can be accessed in the unit testing components. And fuzzing is a special unit testing case, so failure can be used in all those filters could be used in the fuzzing test cases. In the bottom, printer is a very basic component used by logging, so it provides ability to print any compositional type. Then let's move on the detailed C++ stuff, shall we? The first thing I want to talk is pretty printer. In the beginning, I mentioned there are needs to print a container type. One straightforward idea is using a template. Yes, one thing I love C++ is its powerful generic programming pattern. Here is an example. We can write a template function which receives two types, k and v. And for any type of std map, you can always use this template to print it if the type k and v are able to put in the string. You can see the implementation is straightforward. So first we print the left curly bracket, then for each key value pair in the map, so we write them using other stream operator to print type k and v. However, this template only works for std map, which limits its usage. To make a better solution, we can decompose the type based on a list of type traits. For example, printing type t for integer, we can detect directly printed if it's not a character. For container, like I just shown, we can recursively call print for each element. For streamable object, we directly call a stream operator. For smart printer and tuples, we can also grab its content and recursively call print. Actually, this pattern could be used not limited to printing or logging, we said. It's also suitable for usage for other type decomposing. Here is an example of using enable if to match all integer types. Yes, there's not hard if you have used enable if before. Then how about containers? To make one template could suitable for vector, list, other customized containers, we may want to check the begin end method instead of handling for specific templates. Then what I have to do is writing customer type traits to detect those cases. Here is an example. Irritable is a structure. We can partially specialize for matching the type T by detecting if begin and end method as exist. Until now, all those techniques actually you may already know. Using templates, matching the templates using type traits, and writing customer type traits, all standard ways to handle the problem. But quickly you will meet something that's not that easy to handle. So I write another type trait to detect toString method. Then it is saying if there is a toString method in the type T, this type trait will return true. It can be used for some class contains customized toString method, then we directly call that function. However, I find there could be a customer class with both two filters. It's a customer container and it also provides two string methods, right? That's possible. Those type traits are independent and they can happen at the same time. So what will happen? What if a class is a container but also provides a customer two-string method? Will rule be matched? Please raise your hand if you think one is correct. Nobody? Two is correct? Nobody? Okay, so you guys all mean three is correct, right? So if the two rules both match, this causes a compilation error. There is another example of conflicts in rules. If you want to print pointers, you need to avoid char type y. Since const char star is already having a default implementation, so there's an annoying is same t char has been added there. Yeah. Here the reason we have those conflicts is we don't have a priority for those rules. All rules match at the same time. If we can tell the compiler the priority of the rules to match, then this problem solved. The printer could have better code quality and extensibility. In this presentation, let me introduce two approaches used in this framework. One is using overloaded function. Another is using partial specialization. Here is an example. All we need is this template, rank n, is always a subclass of run n plus 1. What we need is to do is putting this rank structure as the last parameter in your overloaded methods. To be careful, this approach requires all methods have exactly same numbers of parameters. In the end, we just need to write a wrapper giving the highest rank number. How it works? The key is to add a new parameter which needs type conversion, which is from subclass to parents when calling the copy constructor. So this way makes the same ranked overloaded function can be used the last parameter to distinguish different ranks. In this case, if we give a type, let's say int, which is 4 bytes, so it will match the second rule, which is rank 2, because it didn't typecasting. Another way is using partial specialization. This makes more sense since it's using inheritance for making priorities. Let's say for the structure foo, which accepts three templates parameters. The first is the target type t, which you want to decompose. The second n is the priority number, the larger the higher, and a void type used for putting enable if. This is a standard way of using enable if in partial specialization so that you can enable the specialized version of the structure foo once the condition is true. At the same time, we partially specialize the t and the rank number as well. You know, when we pass a type t and calls its print function, what will happen? Since there are default value of n, so foo t2 has been called. Let's try to see if there is a specialized version of t. If not, then it will use the general rule. So if you look at the general rule, it says it's inherited from foo tn-1, right? So that the partial specialization rules for 1 could be matched. Until reach the 0 for foo t0, there is an error message telling you that it is not matching. In summary, those two approaches helps manage the priority of the rules you want to match with enable if. This this is not limiting to printing. You will see another example for partial specialization in the following talk. Okay, let's move on the assertion. Assertion is in this framework is quite important. I should say it has two use cases. One is in the user source code, another is in the unit testing. However, there are some slightly different in those two cases. In the user source code, we log the date if it's failed, and we throw exception for the assertion which have severity higher than the error. However, in the unit testing, we usually directly print the message if it failed, since our log system could be suspended during the unit testing. You have already seen the example. And there's another work has been done to count the assertion for final summary output in unit testing. So it calls the behavior different than the code in the user code. So the question now becomes, how should a macro know which environment it's located? Here is a solution. So we define the symbol ZeroErr test context in a global, which is a Boolean type. This is a parameter. There is also a parameter which has the same name in the implementation function of a unit test case. You see, there's no problem because parameter is considered as local symbols. Then in the assertion implementation, interesting part is there is a context helper class which will detect the symbol ZeroErr test context based on its type. So that we can have different behaviors. Here is the details in the context helper. We can have two different implementation based on the partial specialization result. This is C++11 style constant expression implementation. Now, no question, constant expression in the newest version of C++ could be greatly simplified this implementation. Next, let's talk about the logging API. Let's have a look about the idea of structural logging. Here's a log message. From the log statement and output, we could find the log message consists of severity info, date and time, file path, message template, and its arguments. Structural log means we didn't compose the log message at the moment it's created, but we store the structured date into memory so that the structured log message can be accessed since store the word part of the log message instead of whole string. And it's faster and memory friendly since it only needs a memory copy. The stringify step could be delayed and run into another thread if you like. There are also some cases that objects are not copyable, like some date structure is too heavy to copy, or the copy may break the memory management. For those cases, we provide a stringify interface for you to manually call it. You can use the printer to convert objects to string and only store the string here. By the way, you can use other format libraries, whatever you like. Then let's talk about the date structure of a log message. A log message consists of a log info, which is a pointer, time and a tuple of arguments. Log info include file paths, message templates, severity info, which is bundled in the log info, since those information is unique for each log point in your source code. Here, we only store the pointer since this could be shared. The log message is stored into a log buffer, which is unrolled linked list. Each block has a header, which contains the size information for the whole block and some additional meta information. Inside the buffer, there are many log messages storing one by one compactly. Each message have a size at the beginning, which records the total size of the date for that message. Next, let's talk about adding a new log message. To support multi-threading, there are 3 steps in adding a log message. First, use atomic add to move the buffer pointer. Okay, then we should check if the pointer is overflowed. If it does, then log the stream to handle it. Maybe you allocate another block for new memory management. After getting the correct possession of new log message, so you could construct it in position. After seeing the date structure of log message, it's not hard to figure out how it can be iterated. Each message has a size at the beginning, so we can always jump to the next message and look up the metadata to see which log point it is. Once we find the log message we are looking for, the last step is to call stdget to get the value. However, this is difficult. The arguments for stdget is a compile time value, not a runtime value. Then how should we solve this issue? The solution to handle the problem is enumerate all index stdget action may use in a template. Visit info struct can generate a visit function for all index that could be used for a tuple. From 0 to I-1, it recursively matches if the current index equals to the target or not. If it does, it will call a callback function to handle it. Then you need an AND condition to make the recursive stop, right? Here it is. If 0 is reached, so do nothing. And there is a final step. We warp the visit info in using a template function to automatically get the size of the tuple. Okay, finally, let's talk a little bit about Fuzzing API. There are 2 important concepts, domain and groups. Domain is the site of all possible inputs for a data structure. Group is the internal representation of a domain. So for example, a domain of string could be a sequence of elements. Each element's domain could be, for example, 93 to 103. For that case, the groups could be used as a vector of unsigned integers. So our job is to convert it from groups to the real value that could be passed into the function. For Fuzzing API, I don't want to go into too much details since many of them are very similar to fuzz test and auto test. If you are interested in those implementations, so there is already a nice video by Bourbanats in CppCon 2020. But I want to show you another example of maintaining priority of rules in partial specialization, which I mentioned before. Arbitrary is a domain. For example, arbitrary string means each character could be arbitrary. However, it has a similar type trace conflicts, so that it uses this pattern we introduced. Let's see what we have here. Type trace for check is unsigned integer. Check if it is a string, check if it's modifiable, and tuples as well. However, string is also a modified container. If there's no priority, there will be a compilation error. Okay, yeah, that's the technique section I would like to share with you today. By the way, there is a roadmap for this open source project. I plan to add decorators which could mark test case to support better integration with log and assertion. We can improve printing for large, complex types by hidden some date. I'm trying to support binary log date output to reduce the log size. However, there's not easy since the type information is needed when reading the log. The log iterator performance is also another problem. Maybe I could use cplusplus to speed up the query. There are some additional internal domain types could be used for fuzzing, so still currently working on that. There are more fuzzing APIs to controls. So there also allows like custom random number generators, like also extends for other scenarios like MPI. So there are many ideas could be done. Yeah. Okay, that's all for today. Thanks so much for joining us. I'm looking forward to people who wish to try the framework. Also look forward to your any feedback and suggestions. Your contribution matters. Okay. Any questions?
Hi. Can you go back to the slide that you had the Fibonacci sequence on?
Fibonacci sequence?
Yeah, it's quite far back.
Fibonacci 1, okay. That's not. Okay. Is this one?
Yes. So this is a very useful tool for, as I see it, for a lot of older legacy projects that you can't really test well, because by having this here, the logging and checking the logging and the requires and being able to check that kind of stuff, it allows us to not have to deal with refactoring massive chunks of code, but we can still get testing in there by doing some white box testing. However, when I read this code here, it is very not clear to me, and others might disagree, but it's not clear to me how requires would function differently in a debug build, a test build, or a release build. And it concerns me that in this case over here, you have the check throws. So the require is clearly throwing something, but is that only in a testing build? Is that in a debug build? Is that what happens in release? Because in release here, if that throws, I might not be able to catch some specific error handling that I have if n is greater than 20. I don't like, it might, n might never, we might make the assumption that n is never going to be greater than 20. But we can never guarantee that some user input caused some weird thing that somehow managed to get a 20 in here. And now if that's going to throw, and I'm not aware that it's going to throw, I don't know how to catch that. I don't know how to handle that. So one piece of constructive criticism I would have is I think you need to make it very clear what any code that you would introduce into actual code would do in the different debug, release, or testing builds.
Oh, thank you. Thanks so much for your question. So yeah, actually there is no difference for the debug and the release mode for those requires and check assertions. I should say all those assertions will be goes into your final code base. If you don't want to, for example, some of the assertion, or you want to disable this assertion totally, so there is a macro you could define behind before the header when you included it. So, or define in a global way in the compiler when you compile the product. So that can disable the checks. Yeah, but if you didn't do anything, actually it assumes those assertions will always happen.
Yeah, hi. I had more or less the same concern, but what are you going to do if the thing you're trying to test must be no except?
Sorry?
Right? If you're writing a move constructor and you wanted to test your move constructor, and those need to generally be no except. So so the specific question is, you can't use that macro. You could use another one. But then what would your strategy be for getting error data out? Which is a much bigger problem. No one knows how to get error messages out of move constructors.
Yeah,
But it's a thing to think about how you would use this.
I think this log thing, if you would just use the
yeah,
log,
I think you give a
The log would be okay, but then you've got logging in your
I think
stuff,
you
which maybe is okay.
yeah, you give a very good point for that. Yeah, move constructor could be an issue. Yeah.
Hello, thank you for the talk. I'm wondering about the maintainability of log testing. Like with standard unit testing, if you treat your function as a black box, you can change your implementation without changing your unit tests. So now if you're relying on keeping logs and unit tests in sync, I'm just wondering, is there guidance? Should this be used sparingly for like advanced cases where you really need to know the code path, but otherwise try to avoid it?
Thanks for your question. Yeah, actually, this is quite good point, because actually there are some difference about black box testing here. So black box testing, of course, the benefits is you can change the implementation. You do not need to look into the code. But this is not a framework that's designed for that purpose. This is if you want to like make additional safety, so you could check, go to look into the log that you have here. So this test is more tightly bound to the development steps. During your development, you could carefully check everything, but it's not desired for like another group of people to write the black box testing. Yeah.
Thank you.
Thank you. No other questions? Okay, so one more question.
On the screenshot, we see that it prints what the expression is expanding to.
Yes.
Can I ask how you do that? Do you overload a global operators?
Sorry?
How do you do that?
How
we see that inside the macro required there's a variable comparing to something, and on the screenshot.
How did I do that? Actually, yeah, this is a feature called type decomposing. So it's trying to decompose these expressions. Actually, this is not a technique that's made by me. Actually, DocTest, Catch2, they all has these features. So what they did is they first using like operator, a special operator, a stream operator, which putting at the beginning of this expression. And then they have a special expression class, which will reorganize once this, for example, the n passed in, so it will compose another expression there. And there, if there is a like operator, so it will continue building the expressions class. Is building a tree structure for it. So finally, during your evaluation about those each of these expression nodes, so it could be printing what exactly it is. Yeah.
Okay. Yeah. Thanks.
Thank you. Okay, so that's all for today. Thank you, guys.